information, I have to give information about its count also. Okay. So right now I have got only first occurrence of I2. So I have written I2. Now 1. 1 is coming after 2. Okay. So this is conditional. So once we will go to I2, then I can reach I1. Again, occurrence is still 1. Now for 5. I5, still occurrence is 1. This was about transaction 1. Now let's come to transaction 2. It is containing 2 and 4. If I look into this table, 2 and 4. So sorted one is also same. So root node. Now I have to check I2. Is I2 present just after the whenever we come to a new transaction, we have to start the scanning process from root node. So at root node I will check, do I have access to I2? No, sorry, yes, we have access, right, where its occurrence count was 1. But now because of this occurrence I will increase it to 2. Okay. Now 4. Do I have, now I am here, do I have access to 4? No, I don't have. So we have to create a child. Okay. So one child will be created with I4, where count will be 1. It is coming for the first time. I1 is still there and I5 is also there along with their old numbers. Okay. So this was T2. Now let's come to T3. T3, in T3 we have I2 and I3. I2 and I3. If I have to arrange it in this manner, then again 2 and 3. Now this is my previous steps tree, right? So in this tree I have to arrange these. Now again let's check. First is 2. From root node, do I have access to I2? Yes, I have. So root node will be there. Then count of I2 will increase to 3. No issue. Now 3. After I2, I want to go to I3. But here I don't have any path to I3. So see, I1 is already there. I4 is already there. Now I have to add for this I3 and count will be 1. Right? And I1 was already having some count. I5 is 1. Okay. T3. Now let's go to T4. T4 says 1, 2, 4. Okay. 1, 2, 4. Now arrange it according to this table. 1, 2, 4. First 2 will come, then 1 will come, and then 4 will come. Now look into the previous tree. Okay. Here, yes, I2 is there. So count of I2 will be 4. Now 1. Do I have access to 1? Yes, I have. So now this time count of I1 will be 2. It has increased by 1. Now I am here. Do I have access to 4? No, I don't have. So in this case I will add one more node with I4. Occurrence will be 1. I5 occurrence was already 1. Okay. Now T5. T5 states 1 and 3. 1 and 3. For 1 and 3, yes, order is same, 1 and 3. Now look into this previous tree. Okay. This is my root node. Do I have access to 1? No, I don't have. Then in that case, I have to add one more child. See, in FP tree, there will be two cases. One, what is the you know child set of left subtree of root node, and what is the set of children of right subtree of root node. So every time we are just concerned about the right tree. So if we add something here, it is a big deal. Okay. In later stages, you will become more clear. So I have to add 1 3. So now occurrence after root occurrence is 1. So it will be 1. Now 3. After this, I have to okay. So this part will remain same.
So attenuation is this high. What is pointing error? What is the physical attenuation that you
Okay.
How can you correct it?
Now let's go here. T5, T6. T6 has 2 and 3. 2 and 3. Sorted one will also be in same sequence 2 and 3. Okay. So now again check into the previous ones. Okay. From root node 2 is here. So I2 will become 5. Okay. So we know we are going to proceed in the left side. So this part will remain same. Okay. Now come here. It has increased. Now T3. Do I have access to 3? Yes. After 2, we have a part to 3. I3 will be now 2. And rest of the things will remain same. Now T6.
How many bits you have transferred?
T7. T7, I1 and I3. 1 and 3. 1 and 3. Again same sequence will be maintained. Now let's check.
Okay, then how many bits in error that you receive?
1 and 3, right? So simply I know I have to go this side I1 and count will be 2. Again 3, count will become 2. And T7. Now T8. 1 2 3 5. 1 2 3 5. Out of this I have to find. So 1 2 3 5. 1 first 2 will come, then 1 will come, then 3, then 5, right? So here I have access to 2. Okay. So this time I2 will become 6. Here I have access to 1. Yes. So After 2, I have
You were telling that
I1.
you're using vacuum first of all, then you're saying that you were saying that
So
attenuation
count of I1 will become 3.
form and all.
Now 3. After this, do I have 3? No.
Then wherein
So I
vacuum
have
has
to
the issue of
add
fog attenuation or if you're
I3.
using vacuum.
Count will be 1. And after that 5. I5 count will be 1. And these will remain same. No. I6? How did it become I6? I have written something wrong. It was I5. Next is 1, 2, 3. T9, 1, 2, 3. Sorted order 2, 1, 3. Now we have to construct tree from this. Okay. Okay. 2. I have 2. I1 is 2. This part is not touched. Now I2 is 7. Okay. Here I have reached. Now 1. Do I have access to 1? Yes, I have. So now I1. So now my count will be 4. I have reached here. Now 3. After I1, do I have access to I3? Yes, I have. So I3 will be 2 and these will remain same. This will also remain. 5 is 1. Okay, so this is our final FP tray. Okay, now after this, see, whatever is directly connected to this null node, and if occurrence of that particular node is all we don't have any other occurrence. For example, I2 and I1 are connected, and if I check, then I will get to know then that I2 is not anywhere other than this. So I know in that case we will not consider this. We don't have to worry about this. And there, this side I1 is there, and we get to know I1 is here. So apart from direct connectivity with null, it has other occurrence also. So in that case, that other occurrence will be considered. Okay. Now we have to check whether we have included all the items or not, and their support is same which was given. So 1, 2, 3, 4, 5. Let's check for 1. For 1, 1, 4 count is here and 2 count is here, 6. For 2, 7. For 3, 3 is here, 2, 2, 4, 2, 6. For 4, 1, 2. For 5, 1, 2. Okay, so if you will check the above table, then you will find that same 67622. Same occurrence was there, it means it is representing the same data. Okay. Now from here, we have to find out the F pattern. Okay. So for determining the pattern, we have few steps. Just give me a moment for few minutes. I have to make one important call. After that, I will proceed. बस रुक जाओ 10 मिनट. Okay. So now we have found
उससे क्या होता है?
this tree. From this, I have to find out the conditional pattern base. See, when I want to find out conditional pattern base, we will start with the least support count one. 5, 4, 3, 1. And we know we don't have to worry about 2 because it was directly connected to the null node. So 5, 4, 3, 1. We have to find out for these. So for I5. Now look here. ये ले जाओ.
मैम ये 5431 कैसे आए थे?
ये देखो. We are having this sorted table with us. So we will start with the least one and go upwards. Okay.
Yes, ma'am.
So for I5, I have to find out the all the path with which we can reach this I5. Okay, so
Why the issue of orthogonality is important with respect to phase communication?
okay, so I5, one is here and another one is here. Whenever we will be writing the conditional pattern base, we will not consider that particular item. All right, for example, here to reach I5, one path is from null. Okay, I2, I1, and I5. Okay, so we don't have to include I5. Simply, I will say I2, I1, and their support will be similar to this. I1 was having 1, so this will also have 1. What is the another occurrence? This one. Okay, so how will we reach here? I2, I1, I2, I1, I3, and then I5 was there. What is the support here? 1, so it will be 1. Now let's check for I4. One I4 is here and another I4 is here. Okay, so again we will be having two parts. One is I4, I2, I1, and what is the support here? 1. Another one is I2 and support is 1. Okay, so this is our conditional pattern base. Now for I3. I3. Where is I3? One I3 is here, one I3 is here, and another one is here. Now you see, whatever we have got till now was a part of left subtree, but here occurrence of I3 is from right subtree of null node also. So in that case, we cannot merge any path, anything with this. Okay. So when we are making the path, that time it will not be a problem, but in further steps, you have to take care of this. Okay. So I3. Mm, I2, I1, and your support will be 2. Now next is I3 here. I2 and occurrence is 2. Sorry, right. Now next is here. I1, I1, and occurrence is 2. Okay. Now for I1. With this, you just write, some symbol like R, so that in further steps you will not get confused. I1. Okay. So I1 is here.
So, what is
And one I1 is here. But as this I1 is connected to the null node, see, we will not consider this occurrence, only this occurrence will be considered. So in order to reach here, I2. And what is the count? 4. Okay. So these are the conditional pattern base. After FP tree, this was the first step. Next step. Next step is that we have to find out optimal FP tree. So in order to do that, what we have, we will be having, we have to find that FP tree pattern from these. Okay. So again, we will start for I5. Now we have to merge these, and we can merge only, same side patterns only. Okay, this is from left, this is also from left, so I can merge this. See, I2 is here, I2 is here. Okay, I know that support for I2 here is 1, support of I2 here is 1, so I can say that I2 is 2, 1 plus 1, 2. Now I1, 1 is here, I1 is here, support is 1 plus 1, 2. Now see, I3 is also here, but I cannot write it here. Why? Because support will be 1, and in our question it has been given that minimum support should be 2. So here minimum supports rule will come and we will ignore I3. Similarly, for I4, I2 is here, I2 is here. 1 plus 1, 2. But I1 is not in another part, and occurrence support, its support is 1 here, which is less than minimum support 2. So we will ignore it. Now I5, I4, I3. See, we can merge these, but we cannot merge these with this. Okay. So here we will be having 2 sets. Okay. One is for this. So if I merge this I2 with this, what will I get? I2, 4. 2 plus 2, 4. And I1 will be 2. Minimum support count is 2, so we can keep it. For next one, I am having I1. See, even though I1 was here also and here also, but we at this step 2, we cannot merge it. Okay, so it will remain 2. Alright. Now for I1. We don't have to merge anything, so it will remain same. Now from this, I have to find out frequent patterns. In order to do this,
Your number is?
okay. So now we have to generate frequent patterns. Again, for I5, how many patterns can be generated? See, when we were writing these paths here, we did not consider this, right? Now we have to include their end terms. Okay, so now if you will observe here, you will find out that I2 is here, I1 is here. Now I have to merge these with I5. So we have different ways. For example, I can connect I5 with I2, I can connect I5 with I1, and I can connect I5 with both. Okay, so I2 and I5. One is this. In that case, I2 is having 2 support. If I merge this with say only this, I1, I5 support will be 2. Okay. Now combination of this can also be merged. I2, I1, and support, sorry, I5 and support will be 2. Okay, so this is your frequent pattern. Similarly, we have to find more. So I2 was here. We don't have to merge it with anything. So I4, I2, and it will be 2. Similarly for I3. See, this is from left side, this is from right side. Okay, so but when we now this time when we will do the merging, I2, I3, support is 4. I1, I3. Now, when only I1 I am considering, in that case, we can, I will explain it later. Now, if I combine it with the combination, okay, now this time it will become 4. So in this stage we can merge it. Okay, so we will merge, we found 4. Now when we want to mix both I2 and I1, in that case we have to take minimum. So between 4 and 2, which one is the minimum? 2. And as we know that this 2 is still equal to minimum support, so we can keep it. Now for I1 we have I2, I1. Okay, so these are our frequent patterns which have been found with the help of FP growth algorithm. Okay, so question can come, maybe you just have to construct the tree, FP tree only. Maybe some FP tree might be given to you and you have to find out the conditional pattern base, or maybe you have to find out the frequent pattern. Okay. So in next lecture, I will give few questions for practice. Okay. So I will stop my lecture here. Do we have lecture next week also?